Hi there and welcome back. Today we will talk a little bit about how we can use the software Python to post-analyze the data that we have collected with our sensors before. But before we get started, I would like to mention a few things. Python is an open source language, which means that it's completely free and you can download it for free on the internet. When we started to develop this course, our big goal was to make it completely open source, which means that we wanted to be free for everyone who would like to have access to the material and for everyone who would like to learn something about the topic that we are teaching here, which means wearable sensors. And there's something else that's really important for me, namely that I am definitely not an expert in coding, and I'm for sure not an expert in Python. As a matter of fact, I had to teach this language to myself once we decided to make this whole course open source. But I guess this also gave me the chance to understand what's the best way, at least for me, to learn this coding language. And this is a very important thing that I would like to give you on your way in Python coding, namely that the internet and YouTube really helped me learn this coding language better. First of all, especially for the very beginning, I really like to just watch a few YouTube videos, and because there are so many different ones that are tailored to different needs and different expectations, and they really helped me understand the principles of Python. Also, I used Google a lot if there was some specific thing that I didn't understand or something specifically that didn't work on my end, because there is a huge community out there that already asked a lot of questions, and there were a lot of people who could answer those questions already. So I usually always found a solution for my specific problems. It is very important to mention at this point that in this course, I will not go into the details of or into the basics of coding, and also not into the basics of Python coding. What we will actually do here is use Python to solve our specific problems. So I will show you how you can use Python to post-analyze the specific data that we've collected before in the lessons before. Again, and I cannot go enough into this point, if you have any problems with the coding, try it yourself for a little bit, but if you can't find a solution, go online, go on Google or any other search engine and try to search for your problem. As I mentioned before, there have been a ton of people who have asked the same questions, or at least very similar questions to the one that you will have. And there have been a lot of people who have responded to those questions with very specific responses. If you cannot find any solution or any response to the problems that you had, there is also a lot of forums. If you just search for Python forum, you'll find a forum where you can sign up and you can ask your specific question. And since this community is so big, there's usually someone who can respond to your question pretty fast. And then you'll have a very specifically tailored response to your specific problem. I guess with this, I'm done with the intro, and now we can go into how we can analyze the data that we've collected with our accelerometer. Let's do it. Before I go on here, I want to do something that's just kind of like important for me. I really like to change the layout here. So I go on View and Window Layouts, and I like the MATLAB layout because here I also have a few things on this side that I'll explain later to you. So let's just see now how we can create our own algorithm in the file here. So let's just say the same as we did before. Let's say A equals 1 plus 1, B equals, like, say 3, and then let's say C equals, C equals A plus B. Before we see what happens, let's just reset everything that those variables are gone again. Reset, yes. Okay, and then if you click on start, it runs the whole file. So let's now immediately start and try to import some of the data that we have collected with our accelerometer. So in that case, we need to learn how to import a text file into Python. Let me show how one of those files could look like. So on my desktop, I have this file. It's called xdata, so acceleration data. And as I explained in one of the videos before, we have the x-axis, the y-axis, the z-axis, and this is the time. Because the microcontroller is sometimes sending not the x-axis first, but something else, or the y-axis, we might not have the full data set in the first line. And also, if we disconnect our microcontroller, we might also not have the last line full here, okay? Just remember this, that's gonna be a little bit important later. So the first time when I tried to analyze data in Python, I went online and I looked for the best ways how to do that. One thing that came across was a library called Pandas. Pandas is a library that is specifically written or specifically made so that it's easy to import data and to post-analyze data afterwards. To get this library, we need to import this first. And we do this by saying import pandas, and then we give it a name. So we say as PD. So from now on, we can always use this library by writing PD first, and then dot, and then the function that we specifically want to use. So before we can import the data, we need to specify two things. First of all, where's the data the data file located? And second of all, what's the name of the data file? So in our case, or in my case, this here is the path. This is where it's located. It's on desktop, and this is the name, and it's a text file. Hoppala, and it's a text file. So if we click on start now, it will go over this whole file, which means that it will first import pandas as PD, and then it will create this file here. And look there, we now have a file. It's a data type string. So if you want to know a little bit more about data types, I will put a good link that describes different data types in the video description. And here we have now the path to the desktop, and it's called xdata.txt. So it's a text file. And now we can use a pandas function to import our data. This function is called PD. We need to specify it from this function from the library pandas, pd.read_csv. And then we need to specify a few things. So first we need to specify the path and the name, and we have this both in like one thing here. And we could just say import this now. Let's also define to which variable it should import it. Let's say we call this acceleration, this file acceleration data. Let's click on start here and check this out. We already have x-axis, y-axis, z-axis, and the time. And this here is what it thinks the columns are called, but we can actually make that a little bit better. We can actually call the columns, give the columns our own name. So as we have the x-axis first, and the y, then the z, and then the time, we can call them x, y, z, and t. And we can just like add this by saying names equals column names. So now it knows that the names, that's just how it works in this function, that the names will be those four names, x, y, z, and t. And then we can also tell the function what separates each variable, so the x, y, z, and the t variable. And in our case, that's a spacebar. So we can just say t. That's what we had in our microcontroller function before. We said that it should always separate it with a spacebar. This is just this just tells a code to make a spacebar. In this case, it tells the code that a spacebar separates the x value from the y value, from the z value, from the time. So let's now see what happens if we do this here. And there we go. Now we have the values for x, the values for y, the values for z, the values for t. But now the thing is, since, and I explained that to you before, since here we do not have a value here, and we do not have values here, it actually gives this one here a none, which is called not a number. So it doesn't have a number for this. And then here in the end of the file, it also has not a number, not a number, not a number. So we can also just get rid of this by saying, skip rows equals 1. So the 1 is how many rows it should skip, and then skip footer equals 1. So I would always suggest you to do this, because in a lot of cases, the first row and the last row are just not very clean. And sometimes if, for example, I started data collection before I actually started the access that I should do, I would even sometimes say, just skip the first 500 rows, because I know afterwards I actually started what I wanted to do. But let's just do 1, 1, and let's start this again. And let's check this out. So now we don't have the first row anymore, and we don't have the last row anymore. Now that we've imported all our data, we can have a first glimpse on how it looks like by plotting this data. For this, we need to import a new library, which is a library especially for plotting. So this is called matplotlib.pyplot, and we are importing it as PLT. So whenever we want to use a function from this library, we have to do PLT dot and then the specific function. By the way, if you want to see which functions does a specific library have, you can always go to your search engine and just search for this specific word here, maybe with Python or whatever, and they'll let you know which specific functions this library does have. In our case, we want to use the function plot. So this is plt.plot, and then we want to plot, let's say, for example, the x-axis. So that's in this case acceleration data dot x. This does specifically work because we have before used this function here to import the data. So now we do have a data type called data frame. And since we have called the first column x, the second y, the third z, and the fourth t, it is super handy because we can now always just, whenever we want to use this variable, we can just say x data dot x, y, z, or t. So let's see what happens if we run this code now. And there we go. That's the raw data of the x-axis of our accelerometer. Let's now also see what the data looks like when we plot the y and the z-axis as well. Y and z. And there we go. Looks like the accelerometer was lying on one side, was turned afterwards, was turned, and so on, so that every single axis has 1g, or like in that case, 1g positive and 1g negative. In this case, we have just plotted the x, y, and z data. But usually what we also want to have, we want to have the right x-axis. So we can add this by saying x data dot t first. And in that case, the code knows that the first value is the x-axis, the second value is the z-axis. And since our time is, let's check it out here, in milliseconds here, we can just always say divided by 1000, then we have it in seconds, and it's a little bit easier to look at. There we go. Now we can see that the whole experiment was about 70 seconds long. Let's now make this plot a little bit more beautiful by also adding a y-axis label. So we can do this again with the matplot library by saying plt.x label. So now we have an x axis label, and then we can add a y-axis label. We can also add a title here. Let's just call it test. If we also want to get a legend into this plot now, we can create a variable here, variable x, y, and z, and we can say the label of this variable is in that case x, and in that case, Y and Z. And then we can just say plt.legend and see if that works. There we go. Now we have the X, the Y, and the Z axis. So now we have a legend here as well. And lastly, to get rid of the noise of the signal, let's check it out again. So what we want to do is like we want to get rid of these like spikes and those kind of things. We just want to have like clean filtered data. To do that, we can use a Butterworth filter. I'm going to show you here now how we do that. To do this, we need to import a new library. And in that case, that's the SciPy library. And we are importing a function called signal. We don't need to always write as, we can also just use this here directly. So in our case, we want to filter the X, the Y, and the Z axis of the acceleration data. So first we need to prepare the Butterworth filter. And this here is the general code for preparing a fourth order Butterworth filter, whereas the WN is the critical frequency. And in our case, let's just try out 0.05 first. And here's something missing. Oh no, that's not missing. This here is missing. So that will prepare the Butterworth filter. I'm not going into detail of how a Butterworth filter works and what exactly we have to prepare here. So if you want to know more about this, just go online and read a little bit about it. And I might also put some resources in the description of this video and probably into the lab manual. So the next step now will be to use this Butterworth filter, which is this code here. And we now say we want to create a filtered X. So we want to use acceleration data dot X here. And then we can run this. And we can actually now say plot. We can do that in the console if we want to, filtered underscore X. There we go. That's the filtered x-axis. So if we now say plt.plot x data.x, and then we say, so if you click here and you just go up, you can see what you already used before, and you can just go up, for example, in our case, and just click enter, and then it directly uses this line. And here we go. The blue one is the raw data, and the orange one is now our filtered data. Let's now see what happens if we change the critical frequency to, let's say, 0.9. And then let's just put the plot over here. Also, for this, let's create a new figure that it doesn't put our plot into the same, or our lines into the same plot as before. We want to have a fresh plot here. Then let's say plot x data.x, and then plt.plot filtered x. Let's run this and see how it looks like. So now we have two figures. We have the one from before and we have the new one. So as we can see now, if we make the critical frequency higher to 0.9, it's almost exactly what it is before. Let's see now the other way. Before we had 0.05, let's just try 0.01. Let's see what happens now. And there we go. That's way too much filtered. So I guess for this data, what we had before, 0.05, is the best way to go for us. So what I usually do here is I just try. So I plot my raw data, and then I try different critical frequencies just to see which one filters it the best without losing too much of the information of our raw data. So in our case, we obviously want to have the we obviously want to have like the straight line here, and then we want to have this spike up here, and then this data line here, and the data line here. That's important. Okay, and before we finish this tutorial, let's talk a little bit about something that's called debugging. So in a lot of cases, you might have a problem in your code and it doesn't work. So for example, let's say we don't have this WN here and we want to start the code. It doesn't work because it will tell us that WN is not defined. You can also see that there's a problem if you have this red X here, and it also tells you then undefined name and so on. So in that case, as we just saw, if we just add the WN here and we say again 0.05, the X will vanish here and the code will work again. If we have a problem somewhere, like let's keep the same here, and we're not sure why this mistake is here, we can also do something where we put something called a breakpoint. So if you see this red point, you can put a red point here, for example, now. And let's delete our variables that we can see what happens. Reset, yes. We can put a breakpoint here, and if you click here, it runs the code up to this point and then it stops. So let's run it. See, and there it stops now. And then we can just go with this button here, we can go step by step to next. And now if we see, if we look here, we can see that there is, at this point, there is no WN in our variables already. So this line can't work because we don't have a WN here. So we can stop it here. Debugging is one of the most important things that you'll probably use in your programming career and that you'll definitely need at some point in your programming career. It really helps you to just go step by step and always look are your variables changing and how does this affect your code itself. So you can also just start here. Let's go to the breakpoint, and then you just go step by step by step, and you can just see how it creates every single variable, and the next and the next and next. And with this, you can figure out mistakes in your code a little bit easier. Really keep that in mind, and whenever you have a problem, try to use this debugging method. And if you can't find a solution, as I told you guys before, go back to the internet and try to find a solution there. That's it for today. Today we have looked a little bit into how we can post-analyze the data that we have collected before, in our case with the accelerometer. We have learned how to import libraries in Python. We've used the pandas library to then import our data. We have also plotted the data and filtered the data, plotted it again. And in the end, we've looked a little bit into how we can find problems in our code by using a method called debugging. I will also put a very good read into the description of this video. It's called Think Python. So if you want to learn a little bit more about this language, I really suggest you read this short book. It's available online, and I hope that you can find the time for it. And if you will, enjoy it. With this, we're done for today, and see you soon. Bye-bye.